Good morning, Jackson. Good morning, Bentley. I hope that you are recovering from your sickness, and I hope to see you very soon. Connecting a little bit the math lesson that we're going to be doing today with the math lesson that we did yesterday. I wanted to refresh a little bit of the concepts that we covered. So we were trying to see how when we are trying in the candles problem, when we were trying to arrange a certain number of candles into a rectangle, we saw that we could find different ways, different rectangles to arrange the candles. And what I asked you at the very end of the lesson is just to think about this problem in a more abstract way, in the sense that we were having different numbers. I assigned you two pairs of numbers, and you had to think about them as if they were candles, and you were trying to arrange them in different ways. And think about are there many ways that I can arrange these candles? Or is there only one way that I can arrange these candles? So I have right here a poster like the one that I asked you to do, and that's what we're going to start with. So hang on tight while I prepare. I'll be right back. So, as I said, we have this poster with number 18, and I was trying to determine what the factor pairs and the factors for this number are. Just in case you have forgotten, I have here my definition for factors and factor pairs. So I'm going to put it right here. So first of all, I'm going to put it right here. Factors and factor pairs. So as you can see, when we have any given number, in this case 18, which is the one that I'm going to showcase, I can create, and if I had 18 candles, I can create different rectangles to arrange those 18 candles. I can have, one long row of 18 candles. I can have like 2 rows and 9 columns, as I'm going to show you in just one second, or I can have, 3 rows and 6 columns. So each of those numbers that are paired together and I can multiply in order to get 18, they are factor pairs. Now, each of those numbers individually is a factor. Okay, I'm going to move this a little bit. So as you can see, for example, number 16, I can arrange them as 4 columns and 4 rows. So 4 would be one of the factors, or 2 rows and 8 columns. So 2 and 8 would be factors, and together would be a factor pair. Or I can just the long row where it's only 1 row but 16 columns. And that would be 2 factors, 1 and 16, and they together would be a factor pair. So let's take a look at our example with 18. I'm going to pause the video for a second. There's a class coming. There. So they just passed. So I want to show you for number 18 the rectangles that I was able to find out. And my first question for you right now is, are these rectangles, these 3 rectangles, an array? Now you might be thinking, Mr. Rayero, I don't think we have seen or we have not studied the concept of array. Very true, but I'm going to show you a definition and I think you're going to be fine. So look at this. An array is an arrangement consisting of equal rows and equal columns. So I would have the same number of rows and the same number of columns. Look at this. I have some examples for you. So these are all examples of arrays. Now, if I had, for example, removed this square right here, that would not be an array, because then I would have, yes, I would have 1, 2, 3, 4, 5, 6, 7. I would have 7 columns, but I would only have 1, 2, 3 rows with 7 columns. The 4th row would have only 6 columns. So remember, just turn it around. An array is an arrangement consisting of equal rows, equal rows and equal columns. So now the question for you is, are these rectangles an array? Pause for 30 seconds and I'll be right back. If you said yes, they are arrays, you are absolutely right. All those rectangles are arrays. So my second question for you is, I'm going to move the card a little bit so you can see better. What are the dimensions? I'm going to move this so we can see all of it at the same time. What are the dimensions of our arrays? Pause the video for 30 seconds and tell me the dimensions of those three arrays. Okay, if you told me that the dimensions are 1 and 18, 1 and 18, and 2 and 9, and 3 and 6, you are absolutely correct. So now I have a third question for you, and this: what are the factors of 18? Pause the video for a second and we'll come back. Well, the factors of 18 are exactly the dimensions of the rectangles that we just did for number 18. I just put it on the top, but I'm going to show it right here. Look at this. So those are the 6 factors of the number 18. 1, 2, 3, 6, 9, and 18. I also have used what I call the factor rainbow, just so we can see, not only see the factors, but also the factor pairs. Look at this. 1 and 18, 1 and 18 are a factor pair. So I have just created a little arch to connect them together. And the same for 2 and 9, 2, 9, and 3 and 6, 3 and 6. So right there you have the factors and the factor pairs for the number 18. Now, give me just 1 second. I'm going to check my notes and we will move on. Now, what I would like you to do is to go to the attachment that says the student book, and I think I labeled as page 15 to 17. So go to page 15 and work independently on those exercises. When you're done, pause the video. Just one extra thing for that. For those exercises, you're going to use the poster, the equivalent to this poster, just to help you with your exercise. Once we are done with those exercises, what we're going to do in class is we're going to have a little bit of a discussion. Obviously, it's going to be more challenging when you are at home, but just try to think deeply about your answers, and unfortunately, we'll have to leave that discussion for some other day. But go ahead and complete those exercises, and we will move on. And for this section of the lesson, what we are going to have in class is a math forum. I'm going to ask students to work together in order to look at their posters and come to certain conclusions based on the discussion and the work that you have just done. Now, I am hoping to come to a few conclusions. Number one is that if you look at different numbers, you're going to see that some have multiple rectangles and others have only one rectangle. And that is special because that is going to differentiate two types of numbers that we're going to talk about in a few minutes. So if you have realized that some of your numbers had only one box and others had multiple boxes or multiple rectangles, then I would have asked, can you see anything special about all the numbers that have only one rectangle? Pause for a second and see if you can observe anything, if you can come to any conclusion. I'll be right back.
If I'm in there, I don't know.
Now, I hope that you have seen some kind of connection. If you have not, the connection that I was... Hi, Michael. How are you doing?
Good.
Yes, I'm recording my video lesson. Can I continue?
Yeah.
Thank you. Bye-bye. You too. So, I hope that you have observed that mostly those numbers that only have one rectangle are odd numbers. It is going to be more difficult for you to see that because you only have done a few numbers. You have only found factors for a few numbers, and the class has seen many more numbers because they are working in many teams. But that is something that is special. Most numbers that have one rectangle are odd numbers. Exception to that is number 2. 2, if you think about it, only has one rectangle as well. Now, the numbers that have multiple boxes, take a look at them and see if you see anything in common. I'll be right back. Now, the clue of all the numbers with one box being odd might have triggered your thinking into going in the direction that, hey, the numbers that have multiple boxes are even. And that is right. There are most numbers that are even, well, actually, probably all numbers that are even, are going to be numbers that have multiple boxes. Now, you might think, Mr. Rayero, I'm thinking about 15, number 15, and I'm seeing that, and this probably I don't remember exactly if I assigned you on the previous lesson number 15, but I am hoping to see with the class is that number 15 is an odd number, but still has multiple boxes. What's going on with that? And the reason is that not all odd numbers are only going to have one box. There are odd numbers that are going to have multiple boxes. However, most all the numbers that have one rectangle, one box, are going to be odd. And that is the conclusion that I'm hoping to achieve through the math forum. Now give me just 1 second, I'm going to check my notes, and I'll be right back. Okay, so now that we have seen that there are numbers with one rectangle and there are numbers with multiple rectangles, I want to give a special number, a special name to these numbers. All those numbers that only have one rectangle, they are called prime numbers. And I have the definition right there. A number with exactly two different factors, itself and 1. This is interesting. So remember, all those numbers that have only one rectangle, the only rectangle is going to be a one-row rectangle with multiple columns, which are exactly the number of columns that for that number. So I'm going to show you a little bit of a representation. For example, 23, I hope that you can see the number, 23 is a prime number. And as you can see, the rectangle that we can build is one row and 23 columns. That is a prime number. But how do we call the other numbers, the numbers that have more than one rectangle? Okay, those are called composite numbers. Sorry, they're my accent tricking me. So, as you can see, we saw before number 16, and here you can see that number 16, we can arrange 16 candles in multiple ways, in this case in 3 different ways that make a rectangle. So, and each of these factor pairs is going to represent, 2 factors, and it's also going to represent a set of factors that I'm going to track back. Hold on, I have lost my train of thought. It's going to represent the number of factors that we. Hold on, just 1 second. I have to do something else. Well, guys, I have totally lost my train of thought. I went to help Mrs. Marks, and I don't even remember what I was talking about, but the fact that I was talking about prime and composite numbers. So, anyways, what I wanted to tell you is that, remember, a prime number is very likely to be an odd number. We have the exception of 2. And for the composite number, then we're going to have all the even numbers in that group, but we're going to have some odd numbers as well. So not only that. So that is the big thought that I would have brought up during the math forum, and I just wanted to share it with you in case that you didn't realize that during our exploration. Finally, I would like you to go back to your attachment for your student book and go to page number 16 because you're going to be working on that right now. Finally, if you, I'm going to pause the video for a second and I'm going to show you something else.